We have another Nintendo Switch board here, and it was mailed in for an LCD connector replacement. Customer said that he attempted the repair himself, and let's read what the customer said. Missing LCD screen connector, attempted repair myself. That's what Hector said. And let's take a look at the LCD connector and see what's going on. I'm very sure what would take us a short time to fix is going to take us a long time to fix. Missing pad here, 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 and we need all three because you can tell that this pad is going here, this pad is going here, and this one is not needed. It's not going anywhere. This one is not needed, and this one is needed. This one must connect to this via here that connects to somewhere back of the board. So we have to run 4 jumper wires, and then we have to solder that connector. It's a tedious process, but somebody has to do it. I do not know if we have a missing component here. Let me grab a donor board. No, we do not. This pad we do not need because this is the same thing as this. And I was able to tell that by looking at a donor board, that this is the same as this. They share the same line. But since the pad is broken, we're gonna have to restore that pad. And we can restore the pad by running a jumper wire from this point onto this pad here. We can do this later. I mean, this line is microscopic. Now we're gonna prep those lines so we can solder jumper wires. And the jumper wire that we're gonna be using is 0.1 millimeters. A lot of people ask me about it. You can find it on our site, NorthridgeFix.com. Click on shop or search for jumper. I have another video on YouTube where we changed this LCD connector. Today we're gonna do it differently. Last time we did it by soldering the pins. We soldered it pin by pin. Today we're gonna do it by heating the board from under, and we'll see how it goes. You see, when we do not have enough flux, what happens? Just trying to add as much solder as possible on those tiny wires that we scratched, and I think we did a good job. And that's what I love about the fine steel brush. It gets all that goo away. So we did 2 jumper wires. We're gonna have to add solder mask in order to secure them down in place. I mean, we are using a 0.1 millimeter wire. And look at how tiny that trace is. It's smaller than 0.1 millimeters. Smaller, look at this. The wire is maybe twice as big. And we still have one more right here. And we should be good. Clean up. We're gonna add our solder mask. We're gonna tin those wires, and then we'll solder the connector. And like I said, this time we're gonna solder the connector by heating the board from under. I've done it before where we solder the pins pin by pin, but today we're gonna try something different. And heating the board from under is doable because we have minimal components from the bottom. We do not have anything plastic to burn or any connectors. So we're gonna apply heat from here, and the board is thin. So it should be able to absorb heat pretty quick, and we should be able to solder that connector on without issues. I mean, 1 drop of solder mask goes a long way. See, I have like half a drop here, and I can probably do like 10 jumper wires with this. I mean, I do not want the solder mask to be very thick because it's gonna take longer to heal and harden. So I'm gonna spread the solder mask a bit like this. UV light for maybe 20-30 seconds, and the mask should harden. Okay, and the mask is hard. Very nice. Okay, now what we need to do is we need to tin the tip of the wires, just so that the pins from the connector can easily solder onto the wire. So we're gonna scratch the tip of the wire, and it's all precision work. The more precise you are, the less likely it will be that you will have to do the job again. If this board came in without rib pads, we would have been done by now. But like I always say, what can you do? What can you do? Brush off some of that mask from the tip here so the pin can solder onto the wire. And finally we're gonna we're gonna tin the tip of the wire. And you can see how solid the wire is. It's not going anywhere. Okay, so let's add some flux. And we're gonna add solder on top of the tinned wires. See how solder is sticking to the wire easily because we scratched that wire. I mean, this is just one awesome wire. I used to use a wire before where it's a nightmare to stick solder onto. So we are done as far as fixing the pads. Now all we have to do is solder the connector onto the board, and let's see how that is done. The connector is right here. Before we do anything, we need to add flux onto the pins. It doesn't have to be a lot. And to heat up from the bottom, I cannot have this board on the bench. We cannot heat up from the bottom, so I'm gonna have to pull it outside the bench and position the microscope in a way where you can see what I'm doing. Now the microscope is going outside the bench, and I'm gonna have to move this way. Let's see if it's doable. Yep, it's doable, but we're gonna have to hold the board so it doesn't tilt. I'll put something heavy over it, over the board, like the solder holder here. And I'm gonna align it as best as possible, and then we're gonna start heating from the bottom. See, now we can see the pins. Now we can tell where each pin is going. And once we start heating up from the bottom, then everything will come in place, and then we can adjust accordingly. And let's start. So I'm applying heat on bottom of the board. All right, solder liquefied, and let's just wait a second. So I'm gonna hold the connector down since it's a bit solid now, and we're gonna apply heat again, just like that. But of course, do not breathe and do not talk like I'm doing now. Awesome job. Done. I have the connector pressed down. And the connector should be solid from all sides. We did an excellent job. Let's go ahead and test. We want to make sure all the pins are making a good connection. I'm going to start with front of the connector, and let's go under the microscope here, see what's going on. And I have the board tilted with one hand, and we're going to inspect the pins by pushing on them one by one, just to make sure all the pins are making a good connection. Solid. Very good. So far so good. Not even one single pin disconnected. All of them are connected. All of them making a good connection. Wow, every pin is making a good connection. And the wire is, look at this, the wire is moving with the pin. Very good, that's what we want. And the wire should move with the pin also. We made this wire a little bit longer so we can see it more, but the other one is almost even with the pin. Look at this, the wire is moving with the pin. And of course we have our jumper wire to connect the broken trace right here. This side of the connector is perfect. Hopefully the other side is good too. We'll see. I see a bridge here that we have to fix. Actually, oh, it's not a bridge. Okay, it's not a bridge. We want to make sure the pin is making a good connection. Solid. Solid. And the pin is connecting with the wire. Very good. Oh, I mean, we really did an excellent job. Soldering cannot get any better on this connector. Not a single pin out of place. And finally, the wire. And look at this, the wire is moving with the pin. Very nice. We did it. Now the customer mailed this motherboard so we can change the connector, and we did. The job is done. I do not know if there's anything else wrong with the board. Customer said to replace the connector, and we did. It soldered on perfectly. While at it, let me just quickly go over the board. This area is testing good. And let's quickly test this area. And this area is testing good. So there should be no issues with the motherboard. And just one final checkup, and I'm doing this as a courtesy. The USB-C port looks mint, looks very good. So that's it, the job is done. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.